Hello everybody and welcome back to another visual pattern challenge. Today we have villages with animals in them. Here's village 1, here's village 2, here's village 3, and your challenge is to predict the number of animals in village number 4. If you can do that, can you predict the number in village 43? And can you write an equation that could be used to predict the number of animals in any village at all? So that's the challenge. If you'd like to accept it, pause the video and see how far you can get. All right, so let's just look at this first and see if we can figure out what's going on visually. I'm noticing these bears, lots of bears. Number of bears keeps growing pretty rapidly, but then I guess this is a fox. There's always just one fox. So that fox seems like a constant for every village. There's always going to be plus one fox at the end. But the bears, they seem to always hang out in squares. So there's a 2 by 2 square, there's a 3 by 3 square, 4 by 4 square. Aha, so I think in village 5, we're going to have a 5 by 5 square of bears. So 25 bears plus one fox. So my prediction for village 4 would be 26 total animals. Now, you might have an idea what type of pattern this is already. Do you think this is, if you had to guess right now, do you think this is linear? Do you think this is quadratic? Do you think this is something else? Well, let's go ahead and verify the type of pattern by analyzing the numbers. So I'm going to put the village number here and then the number of animals in each village. So in village 1, we've got 5. In village 2, 10. In village 3, 17. And in village 4, we're predicting 26. And then the way we analyze these numbers is by subtracting to find the difference between each step. So between step 2 and 1, 10 minus 5, difference of 5. Between the next two steps, difference of 7. 17 minus 10 is 7. And 26 minus 17 is 9, so there's a difference of 9 between step 3 and 4. We didn't get a constant. This is not all the same number, so it's not linear. We can then go ahead and take the difference of the differences. 7 minus 5 is 2. 9 minus 7 is 2. So we did get a constant in the second order differences, in the difference of the differences. That means it's a quadratic pattern, and we're going to have an x squared in here somewhere. Okay, now we could just use our visual intuition to figure out what that equation is actually going to be, because I think it's pretty clear that fox is just going to be our plus 1, and then we've got this square of bears to deal with. So let's write an expression for the square of bears. Here in step 1, it's 2 by 2 square. Here in step 2, it's 3 by 3. In fact, in every step, it seems like the dimension, the side of the square, is one more than the step. So if we use x to represent the step number, and we add 1 to it, that would be 1 more than the step number, and then we square it. So for example, in step 1, I'd put in 1 for x. 1 plus 1 would be 2. Square that, you get 4, and there are 4 bears there. In village 2, 2 plus 1 is 3. Square that, you get 9. There are 9 bears there. So this expression works to express the number of bears in every village. And then, of course, we've got the 1 fox. We just add that like that. So our equation could look just like this. Now, you could FOIL this out. You'd get x squared plus 2x, and then if you added that together, plus 2. I think I'm going to leave it like this because it so nicely matches the visual representation we have here. Bear, fox. So that's fine for our equation. To calculate how many in village 43, we just plug in 43 for x. So y equals 43 plus 1 quantity squared plus another 1. And let's see, 44 squared is 1936 and plus 1, so 1,937 animals in village 43. 1,936 bears and 1 fox. So how did that go for you? Did you see right away that this was going to be quadratic? Did you get 26 for village 4? Let me know. Thanks, everybody.